They call them the Great Lakes, but they are essentially one giant slow-motion river, flowing west to east, each lake dumping like a bucket into the lake below until all the water is gathered in the St. Lawrence River and tumbles out to the Atlantic Ocean. Like other rivers that flow to the sea, the lakes must constantly be replenished with precipitation. It's been this way since the lakes were carved by the glaciers thousands of years ago. But humans have manipulated the natural system with a series of dams and locks that can speed up and slow down the flow of water out of Lakes Superior and Ontario. Flows have also been manipulated by dredging in places like the St. Clair River, which has increased the volume of water running out of Michigan and Huron, which actually are two lobes of one giant lake. Despite all this tinkering, the volume of water flowing in and out of the system has been so closely matched that water levels have stayed remarkably stable. Lakes Michigan and Huron, for example, have fluctuated about 3 feet above or below their long-term average for more than 150 years. But there are signs that this exquisitely balanced water budget might be headed out of whack. Between 1998 and 1999, the levels for Michigan and Huron plunged more than 3 feet. The bottom fell out and they have never recovered, hitting a record low last January, more than 6 feet below the all-time high. Drought can't be blamed for the drop. The lakes have actually been receiving above-average precipitation most years. So where did all the water go? The volume of water in the lakes at any given time is tied to 3 things. Think of it as a math equation. First, take the precipitation falling over the lakes and the rivers flowing into them. Then subtract the amount that flows out to the Atlantic, and then subtract the amount that leaves through evaporation. It's the evaporation factor that appears to be driving much of the problem, and it starts with a recent jump in water temperatures. The summertime average surface temperature for Lake Michigan at one mid-lake buoy has increased nearly 3.5 degrees since the late 1990s. Air temperatures haven't increased this much. So how did the lakes get so warm so fast? Ice, or more specifically, lack of it. Air temperatures have a profound effect on the amount of ice that stretches across the upper part of the lakes. In the early 1970s, wintertime ice stretched over vast expanses of Lake Michigan, particularly in the north, but in recent decades it has shrunk by 63%. The same thing is happening on Lake Superior, which, on average, has lost 76% of its ice coverage since the early 1970s. Snow-covered ice bounces solar radiation back into the sky. Where there is no ice, the dark open waters begin sucking up sunlight and heat, even in the dead of winter. This has caused a thermal cascade in the lakes. The winter warming gives the lakes a jump start on their annual warming cycle, and that has led to a dramatic increase in peak summertime surface temperatures, and that means more water loss to evaporation when chilly winds blow in. On Lake Michigan, scientists say an increase in the average evaporation rate has taken about 5 feet of water from the lakes since the 1990s, far more than the increased precipitation over that period. And the result of this? The lake is literally getting sucked into the sky.